Hey guys, I'm Janina. I'm currently based in the Netherlands, and currently I work on the iOS SDK of a Dutch payment processing company called Adyen, but before that, as was said, I was at Apple. And today I will be talking to you about how to improve scrolling performance on iOS apps, specifically through some GPU workload optimizations. So in this talk, I will start by talking to you about the difference between CPU and GPU and their responsibilities when it comes to UI layout. Then I will explain an approach that reduces the burden specifically on the GPU. We will then look at a practical example, and I will show you some real results I was able to obtain with it. And lastly, I will discuss when this approach could be useful. But before we jump in, I would like to mention that before considering any CPU, GPU optimization, there are several things you should do that will probably resolve the vast majority of your scrolling issues. So first of all, you should take advantage of UI table view and UI collection view APIs provided by UIKit. So this means using such methods as estimated row height, table view will display cell wherever appropriate. You should minimize transparencies by setting subview background colors to solid whenever possible. You should fix all pixel misalignment by making sure that each frame starts and ends on a full pixel. And the reason for this one is that misaligned images will trigger anti-aliasing, which means that instead of displaying a single color, then the color of the pixel needs to be computed by pulling in all the colors of the surrounding pixels. So this requires extra blending and rendering. And lastly, if you can, eliminate any nice-to-haves that are not that necessary, like maybe if you have rounded corners or drop shadows, and especially if these effects are only seen in specific states of the cells. But if you have done all this and you're still seeing some scrolling issues, then maybe you could benefit from some GPU optimization. So first of all, what are CPU and GPU? CPU is a central processing unit. It's basically the brains of your device. It's responsible for all logic and calculations. And the GPU, or the graphics processing unit, is responsible for rendering and animation, so effects like scrolling, panning, zooming. And actually, the GPU was created to assist the CPU with performing expensive rendering operations. As such, the GPU's final task is effectively to compute what color each pixel should be at any given time and hand that information off to display hardware. So here's what the software to hardware stack looks like. On top, we have UIKit. Below it sit lower-level frameworks like core animation and core graphics, etc. And CPU and GPU obviously live in the hardware layer. And so core graphics works predominantly with the CPU, but core animation is the abstractions on the GPU. And so when it comes to UI, the CPU is responsible for calculating the frames of views, and then it hands each view off to the GPU as a texture. The GPU then composites all the textures and performs blending, overlaying, anti-aliasing, and determines what each final pixel will look like. So scrolling performance issues can occur for two reasons. Either the CPU is spending too much time preparing the cells, or the GPU is performing too many expensive rendering operations. So if you've fixed all the bottlenecks in the CPU, so it may be then worth looking at the bottlenecks in the GPU. Excessive compositing of textures is what overburdens the GPU, in which case you would observe consistent but low frame rates. And the solution? Reduce the number of views by flattening your hierarchy and thus alleviating the burden on the GPU. So here is an example. This is a simple app that I made. It displays a list of movies and their ratings. The data was harvested from Rotten Tomatoes, stored locally in the device. Obviously, the icons are fake. I mean, this app is nothing special. It's just a table view full of table view cells. Each cell has 3 labels and 1 image view. And the labels have computed width to accommodate the size of text. So this would be the traditional approach, which involves creating multiple subviews and sizing and positioning them using layout subviews method of the cell. Once sized and positioned, each of those subviews is handed off to the GPU, The GPU then composites and renders each cell. So in this case, the GPU receives 4 subviews as a texture each. And this is an approach with less work for the GPU. So in this case, instead of 4 views, I have made a single subview called cell view, and I override the drawRect method and draw each element directly onto the screen. I use the drawInRect method on a string and UI image, which are methods from Core Graphics. And as mentioned, Core Graphics does most of its work on the CPU. So then all of this work is done in the CPU, and the GPU would receive this as a single texture. So we still have the same table view cell, but at this point, it only has 1 subview. And the GPU obviously still has to handle the scrolling animations, but now it has far fewer subviews to work with. Oh, and by the way, the reason I did not override drawRect directly in the cell is so that we can still take advantage of out-of-the-box behavior for selection and editing, etc. And so that's it for the actual approach. But the metric we're after here is frame rate. We're trying to achieve as high of a frame rate as the device allows. For this, to measure this, we use the core animation tool in Instruments. Oh, and it's important to run this on an actual device rather than on your simulator, because the simulator uses the resources of your computer, so you're not going to get accurate results. So what happened when I ran this, the 2 versions of the app? Well, on my iPhone 7, nothing much. There wasn't much difference to performance. The device performed great. However, I then ran both of these apps on iPad 2, and for that device, the difference was substantial. So both the traditional and optimized approaches started out at around 55 frames per second or higher for 100 elements. I then repeated the test several times with each version of the app, taking it all the way to 12,000 elements. So the traditional approach plateaued at around 27 frames per second, and the optimized stayed at about 45. So, and the obvious advantage was seen already at about 500 elements, which is the very first large gap. And so there's one more player in this game, and that's auto layout. I rewrote the app one more time, this time using auto layout for an interface builder for each cell. How do you think it did? Probably, as expected, noticeably worse than the other 2 methods. So auto layout immediately started out lower at about 50 frames per second and dropped pretty quickly to about 20, 22. So the problem with auto layout is that it has to use a solver to translate every single constraint into frames. And depending on what the other constraints are is how each equation is derived. So the more constraints you have, the more complex each equation for each constraint becomes. And even something like the order in which constraints are applied can have an impact on what the equation looks like. So it just cannot compare to the simplicity of writing manually laying out. And so there you have it. But as I already mentioned, on iPhone 7, there wasn't much of a difference. So when could you actually benefit from this approach? Well, first of all, if you're optimizing for older devices like me, you don't have to go all the way back to an iPad 2. You could see performance benefits already on iPhone 6, iPhone 5. Or if you're displaying a large number of cells, for 100 elements, there wasn't much different. For 500, 1,000, 2,000, there was. And lastly, if your cells are rich in content. The example I gave you was trivial. It's just cells with just a little bit of text and an image. But what if you're displaying multiple images or different colored backgrounds, gradients, lines, etc.? This approach could be of benefit to you then. So what's the takeaway? Really, the approach boils down to balancing between the CPU and the GPU. You don't want to offload the GPU and then have really overburdened CPU. It's really about balancing the two. And what I just showed you is basically how to reduce the burden on the GPU by flattening the view hierarchy, eliminating as many subviews as possible. And as I previously mentioned, this is a bit of a heavy-handed approach that could be overkill in most cases. If you already minimized number of transparencies, fixed all pixel misalignment, you will probably have fixed the majority of your scrolling issues. However, if you're still seeing lag, then maybe offloading the GPU could give you the boost performance that your app needs. And that's it. Thank you very much.
Thanks a lot.
Thank you very much.
Can you join us and take your mic?
Yeah.
Maybe? Thank you. Thanks. Thank you. It was really interesting talk and with really nice slides. So we have, first of all, questions from the crowd that at some point you are talking about generating some texture to accelerate the rendering, but does it have an impact on the voiceover or accessibility kind of features, or is it just for at the moment of the rendering?
Good question. I haven't tested it with accessibility. Probably has an impact considering it's one view, but I guess in something like accessibility, you can write what your components, you can write the identifier for your whole component, so you would probably have to do that. So that would not be, if you really want individual label, you're going to have to keep it as individual labels.
Okay. Yeah, I got another question. I guess most of, we see that most of Apple applications are really well performing, and there is much time spent for those kind of things. How is it handled? Like everybody at every developer should like know perfectly how performance goes, or maybe there is like a team of expert that goes after.
It depends from team to team. I do think that performance, and especially in scrolling, is just something that's in everyone's mind when they're developing. Everyone's looking out for performance, testing on older devices. QA will come to you and tell you if some device is especially laggy. At some point, you have to stop optimizing. But
in your experience, what are the devices that are especially slow? I'm sure that, I remember of the iPad 1 that was kind of slow, but now it's history. But do you have some recommendations on like, okay, I don't really need to optimize specifically on all devices because you can optimize on a more relative way, but do you have some like pain points with devices?
I guess I had some pain points with my iPad 2.
iPad 2.
But most devices are pretty good, but it's just really more when you have, like in Apple Music, you have such big lists of content, then that's when you start seeing some sort of issues, and writing code that's as performant as possible will also help future-proof this.
Yeah,
all right.
Okay.
Guess that's basically all for the questions.
Yeah, thank you very much for your talk.
Yeah, thank you very much.